Hey guys, welcome back. This is Alex2K, yet with another tutorial. This tutorial is all about render settings, good old render settings. Now, you can access the render settings in different places. One is by clicking on this little guy right there, and that will open up this window, which is the render settings. You can also access it by going into your render window. Let me just bring it up into your render window. You can click the render window, it's going to open it up. And you also have the render settings right there. And then there's another place under the rendering menu. If you go to, I don't even remember. I think it's under render. Okay, window, rendering editors, render settings. There we go. So yeah, window, rendering editor, render settings. That will be the other place you can access it. So you have multiple places. I usually just click here, or on my render window, I would click here, and that's easier for me. So now, as far as that guy, you got different types of renderers. You got Maya software, Maya hardware, mental array. There's also like Maya vector. There's, if you have any external renderer, you probably won't be watching this tutorial because you know how to render. So but there's others. So anyway, um, the main difference here is Maya hardware will render particles better. Maya software, it still render particles, I believe, nowadays, but there's a big difference between Maya software and Mental Ray. Mental Ray will support ray tracing by default, and it gives you extra options like what's it called? Final gather, low illumination, caustics, stuff like that, which Maya software won't. So let's just start here. There's extra settings that I'll talk about. I'm just gonna open up a little teapot scene. I got myself a little teapot there. And I'm just gonna delete this. This was from a prior tutorial. That way I don't have to actually make it. Now, whenever you make a teapot, let's suppose you have refractions, right? So I'm gonna give this a little bit of thickness for the refractions, and it'll allow me to talk a little bit more on something else. So it's a little bit thick, so I'm just gonna look through it inside so you can see the thickness that it has. And let's assign like a refractive or reflective material, so I'm gonna go with a fong and assign this fong here. At the same time, I'm going to make a little spotlight, or you know what, I'm gonna make a directional light. And then we're going to talk about the render settings. Now, if I make a render with Mental Ray right now, then there's a couple of things that are going to happen. One is that this reflective material will reflect the floor, the ground. So like if I made my ground or my floor, I don't know, red, then the reflection will be red. You can see it right there. And the light doesn't have any shadows, because I'm just going to give it some default ray trace shadows there. So you can see the shadow. Just going to put it like this. There's a shadow, there's the reflection, and if I stretch the shadow out a lot, then theoretically by now we should actually be getting the reflection of that shadow. I'm gonna make it even more intense. Yeah, so we should be seeing the reflection of the shadow, which we're not. I'm gonna make a duplicate of this light to give a little bit of bounce. So there's like two shadows there, but whatever. There's this shadow, and we should be seeing that reflection. And the reason why we're not seeing the reflection of the shadow It's because of the render settings. Now, just to elaborate a little bit more, if I duplicated this teapot and put another teapot right there, so I'm gonna make a camera. And look through that camera. And I'm going to put this camera right there and rotate this teapot like that. Let's render that camera. There we go. And let's make that material really, really reflective too. Really, really reflective. Like that. I'm going to take the diffuse down a little bit so that it's even more reflective. There we go. So it's extremely reflective. Okay, so we are seeing the reflections of the floor, and on this teapot we are seeing the reflection of that teapot. I'm gonna go a little bit more crazy. I'm gonna make another material. I'm gonna assign it to this teapot. Also very reflective. A little bit less diffuse, but I'm gonna make the color on this one green. Alright, so we got a green teapot and we got a gray teapot. Okay, so what we see here is on the green teapot, you know what, I'm going to change the color of that gray one. Oops, I'm going to change, let me just put this over here. Change the color of the gray one to maybe blue. A really saturated blue. That way we can really tell the reflections. Okay, so on the green one we have the reflection of the blue one. On the blue one we have the reflection of the green one. On the blue we also have the reflection of the ground, and on the green we also have the reflection of the ground. However, there's a couple of things that we're not seeing. First, on the green one, for example, in the reflection of the green, we should be seeing the reflection of the reflection, you know, like okay, like there will be another teapot like right here or something, and so will be here as well, and then in there will be like another reflection, and so on and so forth, like a multiple reflection. And we're not seeing that for one, nor are we seeing the reflections of the shadows. Now that is because of the render settings, but it's two-way thing. Sometimes it has to do with the render settings, sometimes it has to do with the objects, and back and forth. Now just keep in mind for now that there we are not seeing the reflections of this. I'm going to make a third teapot. I'm going to assign this to a layer, and I'm going to make myself a third teapot, which is going to be in another layer. This one is going to have another material, and let's just make the transparency on this material just 100%. Okay. Now if we make a render by default, nothing, you know, we're not going to see it. We're going to see its shadows, but not the actual. We see the reflections of the teapot, but not the actual teapot. Let's take the reflections down to 0, so it's transparent but not reflective. All we see now is the specular highlights of the actual lights. Let's get crazy. Let's select those lights and take off the emit specularity, since that's actually a cheat of reflections. So now we're not actually seeing the teapot, we're just seeing the shadows that it casts. If we want it, if you know about refractions, then we would give it some refractions and then give it an index like 1.5, and then we're gonna make a render, and then it's gonna be black. So theoretically, now that it has refractions, we should be seeing some of the refractions there. Now you might say, well, you know, this is refracting that black environment. Well, you know, maybe you're right. I know that you're not, but suppose that you are right for a second. So why don't we go ahead and open up the render settings, and what we're going to do is we're going to start by using a setting to make a dome. Usually when you make a dome, you make geometry, but you can do it with the render settings for mental array as well. If you go under indirect lighting, you have this thing called physical sun and sky that I don't like. It's cool, but I don't like it. So we're not going to use that. We're actually going to click on the one that says image-based lighting. And what it does is that it makes a little dome, or a big dome. It's like an infinite dome. It's those yellow lines over there. To which you can either map an image file, or you can map a texture. Now, if you had a cool texture of like, or a cool HDR image, then you might want to use that. But for now, since we don't have that, we're just going to go with texture. And under texture, we're going to click map, and we're going to map an environment texture. We're going to map an environmental sky. Alright, let's try it and see if it works. Let's make a render. So there's our sky, and I'm just going to select this and make it a little bit smaller. And I'm going to make a render from the perspective view so that you can actually see the sky. So that's the actual sky. Now, as you can see, it doesn't have a lot of detail. So I'm just going to play with it a little bit, and I'm just going to change some of the settings on this. Now, this class is not about that, or this lecture is not about that. But I just want to change it up a little bit so that you get some detail there. And what I'm going to do is get crazy, and under the floor attributes, I'm going to take off has floor, and under the atmospheric, I'm going to brighten up the sky, and I'm going to take the elevation down a little bit. I'm going to rotate it so that we can actually see our sun, and let's see if we actually do see it. It seems to be coming from the side. Oh, it doesn't matter. And I'm just going to give it here under clouds. I'm going to use texture. Now for this, I definitely need to make renders out of my perspective view. And under cloud texture, I'm just going to map a cloud. I'm going to make a render. And then the actual cloud on the, it's going to have more density. It's going to have less altitude. Let's see if we see some clouds now. Still nothing, huh? Let's give it more contrast, and let's change the size of it. Still no clouds. Yeah, I know this one takes a little bit tweaking. Okay, you know what? Let's just go ahead and not use a texture because it's going to take too long, and I do want detail there. I'm just going to delete that, and because it takes tweaking and I don't want to start tweaking, so I'm just going to go into image file, and I'm going to look for a environmental texture that I have somewhere. So just bear with me 1 second. I'm going to pause this tutorial right. Okay, welcome back. I just put in a little picture here. It's a panoramic I got off somewhere. I don't even know where. But if you just go from texture to image file and you click the browse and then you look for like a panoramic image that you have somewhere, then you'll find something, and you can see here in the perspective it kind of looks like this. Now I want this one only because it has like detail. You can see some texture there, which is going to be perfect for what I wanted to explain here. If I go render and I go render camera 1, then theoretically we should be seeing some refractions, and we're not. Okay, and the reason why we're not, it's like I said, it's a twofold thing. The way that, as far as refractions go, this object is refracting, or a light ray would be refracting 4 times at least, which would be that outer surface, the inner surface, like this outer surface right there. Then it goes through this inner surface, then it goes through that inner surface, and back through that outer surface. So, if a light ray would do that, then it would refract in here, then it would refract a little bit more, and then go through that surface and refract more, and then come out. And anything that's coming in would have to do the same thing. So the point is that it goes through 1, 2, 3, and 4 surfaces at least. at least. I mean, some other areas will have more. Like if we do, I don't know, if we want like a ray that goes through here, for example, it would have to go through like this surface and that surface and then that surface and that surface and then through the ones that are behind it and then through like those two and then through the other two. So that's 1 2 3 4 5 6 7 8 9 10 surfaces, for example. So that's when the render settings come in. Like I said, it's a twofold thing. First, you have to, like, as far as the material, you have this thing called refraction limit. So if you take that value higher than 6, let's say I'm going to cap it up at 20, that means that a ray would be able to be seen through at least 20 surfaces. And if I make a render, nothing's going to happen because there comes the render settings. You have to actually tell the render settings under quality. You have to go and tell the render settings under ray tracing to as far as refractions to go, let's say 20 surfaces. That's not really gonna do all of it. That's only gonna do part of it. You can see like here, now it's actually seenable. But the reason why it's not is because you need to increase the maximum trace depth, so it actually allows the overall computation to work. And now we're getting some refractions. So before we got black, and now we have some refractions. And like I said, this is the overall limit, and the refractions is the amount of refractions that it'll do. If I do 2, then it's only going to refract twice, and everything else is going to cap down. In this case, we need a minimum of 4. So if I do 4, then most of it is going to refract. Some other areas will be black. See, like there it's black, and here it's black because it has to go through more surfaces. So it says, I can't do it, man, I don't know. So you have to cap that up. Alright? So that's one thing. Now, as far as shadows go, theoretically this should be refracting shadows as well, at least the shadows that are back there and the ones that are underneath. And the reason why we're not getting that is because of the same thing. As far as refractions go, you can also tell both your lights and the render settings to compute the shadow refractions. So that's when you have this number, ray depth limit. So right now, a shadow is only going to refract 1 unit, or reflect 1 time. If you keep it at 10, I'm going to do the same thing here, then that's going to do halfway. The other half is going to be on the render settings. So right now the maximum cap for that is 2. I'm going to make it 10. I'm going to keep this image and make a render. And now you are seeing the refractions of the shadow in here and in other areas as well. Alright, so that takes care of this. And then the reflections is the next one. Now, the one that I started with, if you remember, the 2 little teapots, now they're reflecting that environment a lot. They're also reflecting each other. Now maybe we don't have enough quality to see that, but let's see. We are seeing that teapot and the refractions that it has, and we are seeing this teapot and the refractions that it has. If we were to cap up, you know what? Maybe I'll just hide this guys for a second. I'm gonna make a polyplane here, or a polycube. Try to duplicate it and put it here. So I got two polygons that are facing each other. Just going to assign one material to one, the other material to the other. I'm going to make a render and get them closer together. And rotate it just a tad bit. See if we're able to see the reflections of one on the other. No, we can't. Okay, so I'm just going to select this camera here. The reason why we can't is because of the angle. I'm just going to set a keyframe and go to the next one, and I'm going to put it in a place where you actually do see that reflection. I don't know if you've ever like stand in a mirror where there's a mirror behind. I'm going to give this a rotation of 0.1. and negative 0.1 there. And I'm only doing that because I don't know if you've actually seen that when you stand in front of a mirror and there's a mirror in front of you or and behind you, you will see like the reflection of 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 the reflection. In this case, what I'm seeing here, I don't know if that's too hard to understand, but what I'm seeing here is this would be the outside area is the actual mirror, or this green mirror, and this is the reflection of itself. Does that make sense? And theoretically, I would see another reflection of itself there, and then another reflection of itself there, and then another reflection, and so on and so forth. But what's happening here, the reason why we're not seeing all those reflections is because of the render settings. There's a cap to the reflections and it's set to 1. So if I increase that to 10, I'm going to see 10 reflections of the same thing. And I'm not, so it's probably my angle. Let me just tell this surface, I'm going to take the primary visibility off. Make a render. Okay, so we're seeing the mirror and we're seeing the reflection of the mirror. Maybe it's the angle. There we go. So now we're seeing the mirror and the reflection of the mirror, but we're not going past it. That's because, like I said, it's a twofold thing. So the material, although the render settings are set to 10 reflections, the material, as far as the ray trace options, there's only a cap of 1. If I make it 10, and I'm going to make it 10 on the other one as well, then now we actually see that reflection happening all throughout 10 times. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it just caps out. You know, if I made it, Jesus, I'm going to make it 60, and I'm going to make the cap as far as reflections go to 60 as well. Oh, and then I also have to set it on the maximum trace depth. And I'm just seeing more and more and more and more and more and more reflections. So I don't know if that made a lot of sense to you or not. I hope it did. But as far as the amount of reflections or refractions that you will get, just hide those objects, are based on the render settings and the objects, the materials or lights themselves. That takes care of one thing, not everything though. Then comes, when it comes to render settings, the quality. The reason why this looks really jittery like that is because of the render settings, the quality of it, the aliasing. Right now, a pixel is not like aliasing a lot. Now, usually when you change one thing, you have to change a whole bunch of other things. So to make life easy, you just have these presets here. And you can always switch to production. It's going to set most of your settings. It's going to set the maximum aliasing, which means that one pixel would subdivide itself 16 times. So that means you have sort of like better quality. When you put it in production, the reflections and refractions are going to cap at 10. The max trace is going to be at 20, and the shadows are going to be at 2. So in this case, I can just make those 10, those are 10, and those are 10. That's fine. And if you make a render just by having this, which changed mainly the aliasing settings, then the image is no longer pixelated. It's taking longer to render, but it's not pixelated. It's got a much better quality, and that's because of the aliasing settings. But you know, just to make your life easy, you can just change this to production, you know, because that's going to change aliasing, and it's also going to give you a filter. Now that filter, the gauze, is what's making it a little bit blurry, or it can make it sharper. If I change the gauze to, let's say, 1 by 1, I'm going to keep this image. I'm just going to render this little area. You can see how it's sharper now. But you have other types of filters, like the Mitchell, for example, will also do the same. It'll sharpen up your image, but it's going to take longer to render. And the Langsovs will do the same, but like I said, it's also going to make the render take longer. It's just because it computes with better accuracy. You can see how pixelated, or it's not really pixelated, it's just like really sharp. So if you change that, then you might have to increase the overall aliasing settings, and then your renders might begin to take a little bit too long. It's a little bit. See how long that takes to render? Alright, I'm gonna cancel that. I'm gonna keep it on Gauss. I'm just gonna give it a filter of 2 and 2. The default is 3 and 3 on the Gauss. Now, why would you want to change this sampling levels to a higher amount? It comes really when you're doing stuff like high quality renders as far as size, or when you're doing motion blur, then you might want to change your settings to production motion blur, so that again is going to change a whole bunch of settings, including the motion blur. So you're going to have full motion blur. Now I'm not going to have that on here because I'm not talking about motion blur. Talking about like the main guys here. If you, for example, had a render, if you want to change the size of your render, you would go into the Common tab, and that's where you have a whole bunch of options. You have the file name that you can change, you have the image format that you can change, you have the name number extension so you can render an animation, you have start and end frame by frame, which is going to be every one frame. That would be in the case of an animation. You have the renderable camera, so you can have it to whatever camera you want. You can render the transparency or the Z-def. You can also change, and here's where I want to get to, the image size. By default, you're going to get a 640 by 480 render. You have the options to go HD, but what about poster quality? Like, if you need to do a poster, then you would have to change those settings to like a huge number. Now, if you are making, let's suppose that somebody tells you, oh Alex, you need to make a I need you to make a render that's gonna be a billboard. Alright, I'm actually gonna have a black background here so that I can sort of like draw on top. So suppose that a client or somebody tells you, Alex, I need a billboard, right? Then you ask him, how big is that? And then he's gonna say, oh, it's 40 feet in the width and it's 15 feet in the height. And you're like, oh, okay. And then you ask them, well, the printer that it prints, what resolution does that printer print at? And then they're gonna say, well, that prints at 300 dpi. Not true. Let's say that they're gonna say it's gonna print at 120 dpi. Usually a printer though would print at 300 dpi, but when you're talking about a billboard, because it's so big, they tend to print at that size. But this would be a standard size, right? So suppose they tell you, okay, so 40 by 15 feet, right? So then you're like, okay, so how many pixels is that? Well, you're gonna say, I have no clue. Well, what you have to do is you can figure out an equation, and that is a way for you to know how many pixels you want. The equation goes like this: dpi times inches equals pixels. So if you want to know how many pixels you need to make your render, you just need to figure out this too. In the case of like that 40 by 15 feet, I have to figure out how many inches is 40 feet. Now I have no clue, but I'm just going to multiply it times 3. So 4 times 3 is 12. So that'll be 120 inches by, okay, I'm going to change this to 10 so that I can multiply easier. I'm not good with math. So that would be 40, that'll be 120 inches. 10 times 3 equals 30 inches. Right? So, does that make sense? I think it's 1200 inches by 300 inches. Okay, you know what, guys? Let's suppose that the render is not that big, because otherwise this tutorial would be like 3 hours just making one render. So suppose that somebody tells you, okay, I need to make a print that is 8.5 by 11. Inches. Alright? So you need to figure out how many pixels that is. So then you're going to say, well, DPI times inches equals pixels. So 8.5 times, if we're talking about a regular printer, that's going to be 300. So 8.5 inches times 300 DPI equals I don't know what. And then 11 times 300 equals I don't know what. Since we don't know what, then we need to use a calculator. And let me just get a calculator out here. And it is... Okay, great. My calculator doesn't work. So we're going to get rid of this text so that I can actually open up a calculator. I'm going to type your calc. Alright, so 300 times 8.5 equals 2550. Alright, so just remember that, 2550. Just write it down somewhere. And then 11 times 300, 3300. So 2550 by 3300. So that's how you can figure out your dimensions. So if you would have an 8.5 by 11, it would be 2550 by 3300. Alright? Now, like I said, you don't need to worry about this DPI, this resolution, because you already know the units in pixels. Okay? However, if you were lazy and you don't want to use a calculator, you can change the size units to inches, tell the resolution, and give it the width, 8.5 by 11. And that's going to tell you that it's 25 by 33. So it's the same. Just, this does it for you, but I like to use math, so although I suck at it, but I like to use it. So if you do pixels, you don't need to worry about the resolution. Okay? 2550 by 3300. Alright? Just keep that in mind. Now, when you have a big render like this, if I make a snapshot on my render window, we're actually going to look at my render settings, my frame. We're going to get really close here. Okay? So if I make a render right now, let's hope it doesn't take too long to render. If it does, I'm just going to have to pause this render or this tutorial and come back when it renders. Yeah, okay, so I'm going to pause this tutorial and come back when it renders, okay? Okay guys, welcome back. The render was taking too long, so I just assigned a Lambert onto that object. Now, when you make a render that's so big, with the aliasing settings set to really nice, then anything that's a straight line would be perfect. But anytime you have a curve, you're gonna end up, depending on how close your object is, you're gonna end up having those really sharp edges. That's when a term called tessellation comes in. So you would actually have to tessellate your mesh so that those edges are nice and round. And you really need to pay attention to that. So you would either, like if I press 3, for example, they're gonna curve in a lot better. Or if I did, or if I smoothed it out a couple of times, then I'm also going to get something that's a little bit smoother. So you just have to pay attention into that so that your edges are not going to end up looking like this, but Let me just see if this renders quick. They would be rather a little bit more rounded off. And even here though, I take it to 100% quality, I'm still getting tessellation there. So I would have to still increase. There's ways that you don't have to necessarily increase the tessellation by increasing the geometry. You can sometimes do that under render settings, but that would be an override. So you can increase the samples of aliasing or the tessellation. So you can tell it, right now it's 60, so I'm just going to make it 800 and see if that allows me to have more. Even there I'm still getting that. So yep, even there I'm still getting that. Now this class is not really about tessellation, it's more about rendering. So if you have that, just to keep it simple, because I don't want to make a tutorial about complicated stuff more than it already is. It's the best thing you can do is smooth out your mesh. And if you're in 3, no cancel operation. I'm just gonna press 1. I'm gonna smooth it 3 times. A render will take a little bit longer than what I would want to, but in this case, there's a lot less tessellation. However, as I said, you can always change those values in the render settings, but my suggestion is go ahead and take a read in the tessellation attributes. You can use the minimum and maximum edge length, and that would be the best way. It takes just playing with it, tweaking, so that you can get the correct minimum and maximum edge length, so that the shape actually changes form. But like I said, it's just gonna take some playing with. And yeah, so but again, most of the time you're just gonna have to smooth this, or have really high quality geometry, and that tends to be the case for print whenever you need to get really like real detail, so that you don't get any like weird tessellation. Alright, and lastly, let me see if I'm forgetting anything. So you got the file output, which is the main settings in the command. You got the frame range in case that you have a frame range. You got the cameras. You got the image size. As far as render options, you don't. I would say like enable default light is something I check off. So that way, like if I get a black render, it means that there's no lights, and it reminds me that I have to have lights. You have passes, which are render passes. We're not talking about those. You have features where you can change some of the main features, and like if you're having like a lot of motion with motion blur itself, then you want to change your settings to rasterizer. Otherwise, the skyline is fine. You can activate stuff like final gather, global illumination, and caustics, and all that stuff. Ambient occlusion. You can activate all that stuff in here. If you take ray tracing off, then reflections and refractions are not going to be computed. You can activate your motion blur. You can even tell it just to render the front or the back faces. That's like if you know that your geometry is facing in the right direction, you can save a little bit of render time there. And you got pretty much all these settings like render fur and hair. You can merge surfaces. You can let's see, you don't want to change any of these. You can have it compute lens shaders, or have it compute light maps, or have it compute displacement shaders. Like you check that off and you have displacements, then they're not going to render. If you have that on, then they are going to render. Under quality, you will change the overall quality of your scene. So you can do draft for draft renders just to preview, or preview renders just to do quick previews. You can always have it in production and take down your aliasing levels, for example. We already talked about ray tracing. You don't want to play with acceleration or rasterizer, because it's not really gonna, unless you know about rendering, you don't want to play with it. You got the shadow method, which sometimes something like segments or sorted work faster than simple. and you can, you can tell the shadow linking to be based on the light linking or to be off. So like if you had the light linking and you tell this off, then it's still gonna cast a shadow. Um, and then the what else? The shadow maps is in case that you have shadow maps. And then you got indirect lighting, where you can create or delete this guy that I made, which was the image based lighting. And you can create or delete your physical sun and sky in the case that you use it. You can activate or deactivate low illumination, but you can also do that here in the features. If I activate it here, then it can be activated there. Caustics, I can activate it here, but I can also activate it here in the features. So it's either or. You got multiple places where you can access things. And same with Final Gathering. You can activate it here, or you can activate it here. The more accuracy on the Final Gathering, the more accurate the render will be, and the less blotching you'll have. And the point density will make more of those little blotches, and the point interpolation will sort of like soften out one blotch to the other. So like if I had, I don't know, let's say this, I had a point density of 1, then let's say every 1 unit, there will be 1 of those guys. Now, the point interpolation will soften the distance from one to the other, so it's going to be kind of like a blurred out version. So it ends up, looking less blotchy and more like a big soft shading. So you can increase that point interpolation so that, between them they kind of like blend. And the accuracy is going to have more exactitude as far as how the photons, or how the Final Gathering computes. And I think I'm going to keep it there, because otherwise it's going to be too long. But that's pretty much it though. Okay? The rest is minor details. So just make sure that when you do render, you make sure you render in production. And if you have refractions or reflections, you have to change those values so that you actually see them. And if you need to activate glow illumination and stuff like that, you can activate it under features. And if you need to change the size mainly, you can do it under common. And if you maintain the width and height ratio, if I made it, I don't know, 320, 640 by 480, and I click that maintain, if I just change one number, let's say 320, it's going to change the other side, the other dimension, to maintain the same aspect ratio. Alright, so I hope that wasn't too boring. It's more theoretical than anything else. The rest is just playing with it. Alright guys, so until next time, go and play with your teapots. See ya, bye.